Okay, our next speaker is Chris Ferdinandi, speaking from Massachusetts. He helps people learn JavaScript and believe there's a simpler and more resilient way um, to, to make things for the web. Chris is the author of Vanilla.js podcast guide series, creator of Vanilla.js Academy training program, and the host of Vanilla.js podcast. And today he's talking about the lean web. All right, over to you, Chris.
Cool. Hey, everyone. I am going to nix the video and share my screen. Yeah, thank you. Thank you all so much for joining me today. I just want to make sure like people can see my screen, or you can see my screen at least.
Yeah, you're good.
All right, perfect. Awesome. Thank you both. Cool. Yeah, so I'm going to be talking today about the lean web, some ideas I have for a simpler, faster World Wide Web. And the web is, in my opinion anyways, a bloated, over-engineered mess. And I believe that a lot of our modern best practices are actually making the web worse. And what I want to talk about today is some ideas I have on how to fix it. So an alternate title for this talk is Old Man Yells at Cloud. That really, I think, fits the spirit of this talk quite well. So if you've ever felt like modern web development is too complicated, this talk is for you. And if you haven't, I hope that you'll feel more empathetic to a segment of designers and developers who aren't like you by the end of this talk. I'm Chris Ferdinandi. That's my face. You can find me online at gomakethings.com. I'm known on the web as the Vanilla.js guy. I didn't come up with the term, but I spend a lot of time evangelizing the use of native JavaScript methods and browser APIs instead of libraries and frameworks. I write short guides and create video courses on Vanilla.js. I teach people how to build cool stuff. And I run a project-based training program called the Vanilla.js Academy, which actually opens up again in just 2 or 3 weeks. I've gotten to teach students at some amazing companies like Chobani, 10up, and the Boston Globe. And in what's probably the highlight of my career, Apple used one of my open source Vanilla.js plugins on the Swift website. It's still there today. It's really awesome. You can find it in the source code. It tickles me pink every time I go and look at it. I actually started my career in human resources. And about 7 years ago, I taught myself to code and transitioned into web development. It's an awesome career move, and I highly recommend it if you're thinking about making a career change. I'm self-taught, and so I started by learning HTML, CSS, and messing around with WordPress. And then I moved into jQuery, which was the way to do JavaScript on the web at the time. There were some frameworks that existed, I think Backbone mostly, but they weren't really a thing yet the way they are today. And I wanted to understand more about how jQuery worked under the hood, and if I'm being completely honest, feel more like, quote, a real developer. I had imposter syndrome hard. I was failing my way through a lot of the JavaScript-based interview questions while I was trying to look for work. So I started learning Vanilla.js. And at the time, browsers were finally standardizing features and implementations. So cross-browser compatibility was so much easier than it had been in the past. CSS3 and HTML5 were out. JavaScript's ES5 was out, and it pulled a lot of features from jQuery. In retrospect, it feels like the perfect time to have tried to learn this stuff. I look at the state of things today, and I feel like I wouldn't have been able to teach myself or make the jump into web development if I tried to do it today. It just feels completely bonkers. I want to help others feel like they can do this too. So every weekday, I send out short emails with code snippets, tools, techniques, and random awesomeness from around the web. Everyone who subscribes to my newsletter gets an email from me asking, what's your biggest challenge in web development? And I get back a lot of responses, but the one I get back more than any other is some variation of this. My biggest challenge is keeping up. I'd say this makes up at least 50% of all the responses I get back. Not always exactly in this language, but that's always the undertone of what people are telling me, that they just have trouble keeping up with the insane change of pace in the web development industry. The good news is there's a movement towards simplicity happening on the web. In 2018, Thomas Fuchs tweeted, "Is there a conference for web developers that specifically caters to, quote, lean web? Don't use JS if not necessary, etc." He's used the term the lean web a few times since then. And as far as I know, he coined the term. I really like it. And this ethos is what I'm going to be talking to you about today. So here's the agenda for this talk. We're going to spend a little bit of time looking at some modern best practices and why I think they're bad. Then we're going to explore how we got here in the first place. And finally, we're going to look at a set of new best practices that can take us forward to a faster, simpler web. So with that started, let's dig into some of the modern best practices and why they're bad. If I had to sum up modern web development in one sentence, it would be this: JavaScript, all the things. So much of modern web development is built around JavaScript. Sometimes it feels a bit like this. And if you're listening to this, if you're visually impaired, you have a waiter who's supposed to be a developer pouring a human-sized bottle of olive oil, which is supposed to be JavaScript, onto a salad, which is supposed to be a typical website. At the heart of most modern development best practices are JavaScript frameworks like Angular, React, and Vue. They're listed on almost every front-end developer job description I see. What framework did you use is a pretty common question when someone announces an awesome new project. So what's the appeal of these tools? One of the big attractions to frameworks is how they create user interfaces. Let's say you wanted to build a to-do list app and you have some data about the user and their to-do items, whether or not they're completed, what the to-do item actually is. And you want the UI to look something like this, with a field to add to-dos and a list of their to-do items. Completed items might have a checkbox next to them and be struck through. And whenever someone adds a new item or completes an item, you need to update the UI. With traditional DOM manipulation, this would require getting the last item from that to-do list, creating a new item and appending it in, or adding a class to an item when it gets checked off. And if they had no to-do items, maybe you want to show a message asking them to add one, which requires you to target the UI differently than when they add their first item. Frameworks use an approach called state-based or data-based UI. You create a template for a piece of user interface and tell the framework, if my data looks like this, do this. If it looks like that, do something else. Instead of updating the UI directly, you update your data, and the framework handles the rest. So in this case, we could say, if we have to-do items, actually show them. If you don't, return a message asking them to add their first one. Instead of updating the UI directly, you update the data, your framework handles the rest. And it uses a process called diffing to look for differences between the current UI and how it should look, and updates only what's needed. It's really, really smart. The big well-known frameworks like React and Vue use something called the virtual DOM. This is a JavaScript-based representation of the real UI that it uses to figure out what needs to be updated when in the UI when the data changes. When working with really large data sets, it can be more performant than trying to query the actual DOM. For apps that need to perform, quote, at scale, this is an often cited benefit of frameworks. And because established frameworks are used by thousands of developers at hundreds or thousands of companies, you have more people testing the code, finding bugs, and pushing fixes. Ideally, the code is more resilient. You may be thinking, this all makes sense and sounds good. What's wrong with this? Well, one of the main arguments for using frameworks is the performance benefits that they bring, but frameworks also cause a lot of performance problems. We talk about performance at scale a lot in the context of frameworks, but these tools were designed by companies who deal with a level of scale that most of us will not. Most of the sites we build don't have Facebook or Twitter-sized data bundles, and most sites we build will never get there either. We like that frameworks have tons of bug fixes baked in, but many of them are fixes for weird edge cases we'll never encounter and features we don't need. We're inheriting solutions to other people's problems, not just ours. And all of that JS that we load for the scale issues that we don't have and the edge case bugs that we're not encountering has a huge impact on performance, particularly first page load. We're sacrificing initial page load performance, our user's first impression with our site or our app, for the hopes of faster page loads later. And I'm not so sure those trade-offs are worth it. Because of how browsers work, JavaScript is much worse for performance than the same amount of HTML or CSS are. Adi Osmani wrote a really great article about this last year called The Cost of JavaScript. Adi Osmani, by the way, is a performance specialist and developer at Google. He wrote, byte for byte, JavaScript is still the most expensive resource we send to mobile phones because it can delay interactivity in large ways. A few years back, there was a movement called One Less JPEG. I don't know if any of you remember this, but the argument was that rather than worrying about 200 or 300 kilobytes of JavaScript, about the size of a framework and all of the front-end code to render a UI. Just use one less JPEG, about the same file size, and get on with it. Maybe that hero image on the homepage. The problem is, it's not just about download size. JavaScript is so much more demanding to parse and execute. It blocks the page from rendering. It blocks other files from downloading. It can't just be run after the browser receives it. It needs to be parsed, compiled, executed. And there are a number of other steps that an engine needs to complete. Earlier this month, Zach Leatherman tweeted out, which has a better first meaningful paint time, a raw 8.5 megabyte HTML file with full text of every single one of my 27,506 tweets, or a client-rendered React site with exactly one tweet on it. Spoiler, Lighthouse reports that the 8.5 megabytes of HTML wins by about 200 milliseconds. That's a fifth of a second. Just think about that for a second. JavaScript performance is so much worse than HTML that 250 times more data in HTML loads faster than a fractional amount of JavaScript. Which brings us to package managers and module bundlers. Because these large JavaScript bundles create performance issues, we started using package managers and module bundlers like Bower, Yard, Webpack, Parcel, and Rollup. They handle dependency management, figuring out what JavaScript files to include on any given page based on what else is there, rather than loading all of the things on every page. Newer package managers also offer something called tree shaking, in which code that isn't used and doesn't need to be included gets dropped out. So you might need a particular file on a page, but you might not need certain things within that file. And so those get stripped out, giving you the smallest bundle possible. This isn't a terrible idea, but the trade-off for this approach is a high setup and maintenance cost. Because of all the moving parts and deep dependency trees in these modern approaches, getting set up in the first place and then maintaining that setup can be expensive and time-consuming. Getting new developers set up with everything they need to work with your code base becomes a complicated, delicate balance. If you're anything like me, you've been on jobs before where you spent the first week or two just trying to fight terminal and debugging setup processes to get what you need in place to actually start writing code instead of building the awesome stuff you were hired to do. And if one of those dependencies somewhere in your chain gets out of date, the whole build can come crashing down around you. The tools that are supposed to help us and save us time often end up costing us more time because of tiny gotchas. Kyle Shevlin tweeted out, my workflow today, 15 minutes of writing code that works and does what I want, and 2 hours of trying to appease the static type gods. Another example from the insanely talented Brad Frost, that depressing realization that the thing you're slogging through in a modern JS framework could have taken you 10 minutes in jQuery. Nicole Dominguez shares similar thoughts about Webpack. Webpack, JavaScript, turning a 1-hour project setup into an 8-hour affair. Or J.R. Cook, who learned the hard way, writing, I made the mistake last year on my team to push one of the apps we were developing from just using jQuery and vanilla JS to using Angular because I assumed it would make our lives easier. It did not. It just added complexity. Another popular modern best practice is CSS in JavaScript. CSS in JavaScript is supposed to address some of the challenges of working with CSS in a component-based design system on a team of developers who are sometimes more comfortable in JavaScript than CSS. Let's say you had a component with the class of callout on it, and it was styled like this, with a background color of slate gray and a font size of 2ems. There's a chance that other components in your UI might also have a background color of slate gray or a font size of 2em. Over time, you end up with a lot of redundancy in your style sheet. There's also a chance you might create a component with some styles that later gets dropped out of the project and then forget to remove those, which adds even more bloat. In CSS and JavaScript, you might do something like this. Instead of adding an explicit callout class, you add this bracketed callout object as the class. And this gets run through something like React or Angular, rendered out from JavaScript into HTML. You add your styles pretty much the same way you would add CSS, except they use JavaScript conventions instead of CSS ones. So it's an object assigned to a variable. And you've got background color camel-cased, font size camel-cased, but overall it's kind of the same. That gets rendered into something like this. You've got these really random class names that look nothing like what you passed in. The idea is that each property gets broken up into its own class and added to the element, so you can reduce that redundancy. Only what's needed for the page is loaded, and you avoid issues with the cascade trickling unwanted styles into other elements. So in this example, that JRP's first class might be the background color of slate gray. That Nibe second one could be the font size, and those other two might be some other individual properties that get added to this element. Nicholas Gallagher, formerly of Twitter Engineering, shared this data on Twitter's move away from their legacy code base to a CSS and JS solution, writing that the legacy site downloaded 630 kilobytes of CSS, but their new one that uses CSS and JS and builds itself incrementally generates just 30 kilobytes. That's a really, really impressive reduction in file size, but I can't help but feeling like 630 kilobytes of CSS is just an unnecessarily large amount of CSS for what the Twitter UI was in the first place. I just literally don't know how they got that big. And as we'll see in a little bit, the resulting code from the CSS and JS solution is effectively the same as some other purely CSS-based techniques, but with a lot of extra tooling and fragility around it. You end up with classes that are completely unreadable to humans, and this makes debugging UI issues harder too. There's also another consequence, gatekeeping. It excludes people without JavaScript expertise from the process. And in my experience, people with deep specialized CSS expertise don't always have the same level of comfort or proficiency in JavaScript, nor should they be expected to. These tools exclude people who have important essential contributions to make from participating in the process. Alex Russell is a developer on the Chrome team. In his 2018 article, The Developer Bait and Switch, he talks about a straw man argument that people make around using frameworks. Excuse me, writing, here's a straw man composite from several recent conversations. These tools let us move faster. Because we can iterate faster, we're delivering better experiences. It probably does improve the experience for some developers, specifically people who are more comfortable in JavaScript than other parts of the stack. But for people who specialize in CSS and semantic HTML or web accessibility or user interaction patterns, it can leave them shut out of the development process in ways that they weren't before. In 2018, accessibility consultant Rian Reitveld resigned from her position as the WordPress accessibility team lead and documented why in a detailed article. The TLDR on this was that Gutenberg is the new WordPress editor, and it's built on React. Because of that, and because no one on Rian's team has React experience, and they couldn't find volunteers in the accessibility community who did, they couldn't effectively work on improvements themselves. They had to figure out a way to explain them to developers who wrote the code in the first place and send it back to them. So it just kind of slows the whole process down and means they can't directly do the work that they've been tasked with doing. And in May of this year, a detailed accessibility audit of the new Gutenberg editor was conducted. It was 329 pages long, detailing various accessibility issues. The executive summary alone was 34 pages, and it documented 91 accessibility-related bugs in quite a bit of detail. Now, these are not overall bugs. These are just accessibility bugs. These tools may let some developers on your team work faster, but I'm not convinced that they let all developers work faster, nor that they result in better experiences for your users. That straw man argument that Alex hears all the time. One of my students shared this React developer roadmap. Things in yellow are items that are considered must know. And the amount of, quote, must know items on this list is absolutely staggering. In my personal opinion, very few of these are actually things you have to know. But this kind of thing is super alienating to beginners, and it's really prevalent within our industry right now. There's another way we've attempted to get at this performance issue, single-page apps. With a single-page app, the whole site or app exists in a single HTML file. JavaScript renders the content, handles URL routing, and so on. Only content refreshes, not your JavaScript and CSS files, which is theoretically better for performance than having to re-download all those files for any particular page on your app. It also allows you to create fancy transitions between pages, which a lot of developers or designers really, really like. But this also breaks a bunch of stuff that the browser just gives you for free out of the box, which you then need to recreate with JavaScript. You need to intercept clicks on links and suppress them, figure out which HTML to show based on the URL, update the URL in the address bar, handle forward and back button clicks on the browser, update the document title, shift focus back to the document. All this stuff that the browser just does for you out of the box by default. This feels like a vicious circle. We're literally breaking the features that the web gives you out of the box with JavaScript, then fixing those performance issues that we created with the JavaScript with more JavaScript, and then re-implementing the features that those fixes break with even more JavaScript, all in the name of performance, which again, we ruined in the first place with all of the JavaScript. It's just bonkers. It makes no sense. Our over-reliance on JavaScript has created a front end that's incredibly fragile. The smallest mistake can cause the whole thing to come crashing down. We run into things like empty white screens when you go to visit a web page. This happens because the HTML the server sends is nothing but an empty div, and real markup is rendered entirely with JavaScript, which might work great, except when that file fails to load for some reason or just hasn't loaded yet and you get nothing. And yeah, it's 2019. JavaScript is an integral and important part of the web, and most people don't disable it. But CDNs fail. In July of this year, a bad deploy took down Cloudflare, a CDN provider used by 10% of Fortune 1000 companies. No CDN, no JavaScript. Firewalls and ad blockers get overly aggressive with what they block. The absurdly large JavaScript files that we send time out on slow connections. Ian Feather, an engineer at BuzzFeed, shared that about 1% of requests for JavaScript on their site fail. That's 13 million requests a month. People browsing on mobile devices while commuting go through tunnels and lose internet. And obviously no one sets out to write code with bugs in it, but it happens. And when it does, JavaScript is the most fragile part of the stack. If you fat thumb the keyboard and type DVI instead of div, the browser ignores what you wrote, treats it like a div, and moves on. If you mistype a CSS property, for example, writing BG color instead of background color, the browser just ignores the property and moves on. But let's say you misspell a variable name in your JavaScript, writing num as NMU here. The JavaScript file would throw an error and just stop. Any code that was supposed to run after this function was invoked would stop working. HTML and CSS fail gracefully. JavaScript does not. To understand what a path forward might look like, I think it's important to understand how we got here in the first place. To answer this question, we need to take a quick look back at the history of the front end. Historically, the back end has had more credibility. It's where serious business by real developers happened. The front end was a plaything. It was for fan sites built on GeoCities and random musings on LiveJournal. It was under construction banners and the Blink element, which I miss tremendously. It was really experimental, weird stuff with typefaces. Yes, I believe that is Comic Sans. And LeetSpeak, and really interesting fan sites for things like Doom level design, and just all sorts of crazy weirdness, but like in a really fun way. Now the web is a platform where serious work happens. It runs full-on applications people can use to create presentations and spreadsheets, edit photos and videos, and have real-time conversations with people halfway around the world. It's an amazing piece of technology. Many back-end engineers moved over to the front end and brought with them their best practices. Because of our historical lack of credibility and our emerging maturity and desire to be taken seriously, a lot of front-end developers latched onto these best practices too. You hear it in statements like, I need frameworks because I build apps, not websites. And vanilla JS doesn't scale. And CSS isn't a real programming language. But here's the problem with applying back-end best practices to the front end. The back end is not the same as the front end. They're fundamentally different. In the back end, you have all sorts of control. You can control what the operating system that your code runs on is, when it runs. You can control the storage and RAM and bandwidth that's available. There's this predictability. On the front end, you have no control. What we build is accessed by devices of varying capability, used by users of varying experience and technical skill on networks of varying strength and reliability. We keep throwing more JavaScript at things in an attempt to force the control we get in the back end onto the front end, but that's not how it works. Trying to fight the nature of the medium is the source of a lot of the pain that we feel with the modern web development. So with that in mind, let's look at a new set of best practices, lean web principles that we can use to build a simpler, faster web. I want to encourage you to, in a way, become a developer dinosaur. We are, as an industry, obsessed with shiny new things, new techniques, new tools, new trends. It's what makes this profession so exciting, but it's also what causes that feeling that you can't keep up. But old techniques don't become invalid just because new ones come out. Often the older approaches are simpler and more reliable than the new ones. For example, bicycles are still a good transportation option, even though cars still exist. They're easier to maintain, they don't need gas, they're quieter. You don't need as much training to use one. They can go places cars can't. My mountain bike is 20 years old. I fill the tires up with air when they're low and oil the chain every few years. Honestly, it's probably been like 6 or 7 at this point. And that's it. It still works. The same is true for development tools and techniques. That doesn't mean you should never use new tools and approaches, but I want to encourage you to be more selective about what you use and why. Does the utility outweigh the cost of using it, both for you and your users? Lean on old trusted approaches, but augment them with new tools and techniques when it's beneficial to both you and your users. So the first lean web principle is to embrace the platform. Rather than using dependencies or libraries, use the native JavaScript methods and browser APIs that are baked right in for free whenever you can. Stuff that used to be really hard, like getting elements in the DOM and manipulating classes, is really easy now. The first line here is jQuery. The second is the equivalent in vanilla JavaScript. It's a little bit more verbose, but it has the same simplicity about it. Get the element, add the class. Here's some JSX code I copy-pasted from the React documentation website to create a hello username interface. And here's the comparable thing in vanilla JavaScript. You can see, I'll just toggle back and forth for a sec. It uses the same basic syntax. It's slightly different with the vanilla JS because there's the $ in front of the name variable. But the vanilla JS version is actually a little bit more brief in this particular example. And you get the same convenience that you would in the React version. Sometimes the platform provides HTML elements to handle stuff that would otherwise require JavaScript. For example, the details and summary elements create accordion components. They're accessible, can be styled, and even emit an event you can hook into JS if you want to extend them a bit to make, for example, a group of accordions where only one item can be opened, and opening one collapses the others. You can get native HTML autocomplete components with a humble input element and associating it with a data list element. So here we can autofill from a list of wizards. Similarly, CSS can handle a lot of stuff that you would historically use JavaScript for, animations in particular. Daniel Eden has built an entire library of CSS animations that you can poach from. Most of them are really, really small. They're more performant than JavaScript equivalents would be, and they're just really simple and nice to work with. My most popular JS plugin, the hardest one I've ever written, is a vanilla JS smooth scroll animation plugin. It animates scrolling to anchor links on a page. One line of CSS now does the same thing. Smooth scroll, scroll behavior smooth. For accessibility reasons, you should disable this behavior when prefers reduced motion is activated. So you add a couple lines there, but it is really, really, really slick and smooth and awesome and ties into your browser's refresh rate, and it requires no JavaScript at all. Routing is something that browsers handle for you already out of the box. And then with single-page JavaScript apps, we break it. So we add even more JavaScript to put it back in. The argument in favor of SPAs is that they're more performant because you avoid that expensive page reload. But there's another way to get fast page loads and remove that complexity. Instead of a single-page app, you can have, and I know this is groundbreaking here, a multi-page app where each page renders a different part of the app, and you let the browser handle the routing for you. So the login page, the dashboard, the account management page, the home page, they're all their own separate HTML files and not a single page app. You can still render content with JavaScript if you want. You just do it across multiple HTML files instead of one. That doesn't mean you have to render all your markup server-side or use database-driven websites. In fact, it's actually probably better if you don't. When someone first visits a web page for a database-driven site, like WordPress, for example, or Drupal, the server pulls content from the database, figures out which templates to use, and then combines the two into HTML, which it then sends back to your browser. This takes time, and depending on your server, it can take a lot of time. With static HTML files, like you get out of something like Jekyll, the response is nearly instant. The browser requests a file and gets one back. Couple this with sending less code down the wire in the first place using some of the techniques we just talked about, and you get nearly instant page loads. Here's a video I captured of me navigating through the portal all of my students use to get access after they buy one of my courses or guides. I serve up the won't ever change markup, like navigation, H1 headings, page titles with static HTML, and the main body content, which is specific to the user and what they've purchased, comes from an API that gets rendered with JavaScript. And as you can see, these page loads feel nearly instant. It feels like a single page app, but it's multiple separate HTML files, so I don't have to worry about click intercepts and URL paths and recreating all of this browser functionality. It's just handled for me. If your site or app is just a few pages, you can create these by hand, but I'm assuming if you're at a conference like this, you're interested in things like static site generators, like Jekyll, Hugo, 11D. They all have their pros and cons. And they give you the benefits of working with a database-driven site, having, markdown content and templating, but without the performance hit you get from some of these older technologies. Whenever I talk about this technique, I always get asked about, what about persistent data that should carry across multiple views? Honestly, I use session storage or local storage for that. I usually create a couple of helper functions, one to write data down to session storage or local storage whenever it gets updated, and another to extract it when the page first loads. And it will return back an empty object if there's no item in local storage. It's really simple. It gives you some really nice performance across different views. Highly recommend it. Second lean web principle is to keep things small and modular. It's common practice in our industry to reach for multi-purpose tools. Look at all the utilities that are baked in. Features are good. We go for the multi-purpose utility knife when really all we need is a pair of scissors. Perhaps we should instead be reaching for small focus tools that do just one thing well, and at that, only when the platform alone won't work. Instead of including 27 kilobytes of Lodash to just use one or two helper functions like group by, you could include a 0.15 kilobyte, just 150 byte helper function that does the same thing. Instead of loading the entire jQuery library and jQuery UI to add toggle tabs, you can load one built on top of native browser methods and APIs, a la vanilla JavaScript, instead. Instead of loading 30 kilobytes of Angular or React or Vue, I think Angular is a little bit more than 30 kilobytes. You can use HyperHTML, which is less than a kilobyte after minifying and gzipping. Or Preact, which is a 3 kilobyte alternative to React with the same modern API. Or Reef, my own 2.5 kilobyte library that does state-based user interface with DOM diffing and data sanitization, much smaller footprint than you get with something like Vue or React. Or Svelte.js, which pre-compiles, much like static site generators do, all of your JavaScript templating into 100% vanilla JavaScript that gets served up to the browser. Earlier, we talked about CSS in JavaScript. It helps prevent redundancy in your style sheet by creating these separate classes for each of the individual properties that you set for a particular component. And so in this example, like you might have another component that also has that background of slate gray. It would have this JZRPS class on it too. It's a great approach, but you don't need a JavaScript tool to do this. Object-oriented programming, or OOCSS, was invented by Nicole Sullivan quite a few years ago. If you're familiar with things like Atomic CSS or Utility First CSS, they're derivative of Nicole's work, although she seldom gets the credit she deserves here. Object-oriented CSS treats CSS classes like Legos for front-end developers. Looking at that same component again, instead of styling the component directly, you would create utility classes for what you're trying to accomplish. In this case, BG-gray to give that background color of slate gray, and text large for that font size of 2M. This is effectively the same result as the CSS and JS example, but with classes that you can read and understand. Initially, this seems to result in more CSS to accomplish the same thing. And for any one component, that may be true. But once you get a small collection of these in your project, you can start to mix and match them across components to get the look and feel you want without adding more CSS to your code base. It also helps drive more consistency across the UI, reducing the chances of any one component having slight variances in things like color or typographic scale. I'm sure you've all run into websites before where like the button on the sign-in page looks different from the button on the register page, looks different from the button in the actual app. And you can tell different developer teams worked on these and styled the component differently. And object-oriented CSS helps eliminate some of that. If this sounds interesting, Nicole has a fantastic presentation on it available on SlideShare that I highly recommend. The last lean web principle is that the web is for everyone. I advocate for using what the platform gives you whenever you can, but those native features aren't available on every device and every browser. One of the biggest advantages of libraries or frameworks used to be that they standardize behavior across browsers. But you can do that today with polyfills, little snippets of code that add support for features to browsers that don't natively support them. So here's a polyfill for the array for each method. It checks to see if the feature already exists in the browser. And if it doesn't, it uses older code, in this case, an old school for loop, to replicate that native feature. Polyfill.io from the team at Financial Times is a free service that makes using polyfills like this super easy. You include it on your site just as a script element, like you would any other JavaScript file. And it automatically detects the user's browser and sends back only the polyfills they need. So on the latest version of Chrome or Firefox, you get back nothing. And in IE8, you're going to get about 17 kilobytes, about half the size of your typical framework, minified and gzipped. Progressive enhancement has fallen a bit out of favor lately. There's this line of thinking that says that people shouldn't be turning off JavaScript in their browsers. And browsers are free, so they can always upgrade. And as we talked about earlier, most JavaScript failures are not because someone deliberately disabled it. And people don't always have a choice over which browser they use. Progressive enhancement or building in layers adds what Jeremy Keith calls fault tolerance to your site or app and helps ensure that as much of it is as usable as possible to as many people as possible. There's a belief that progressive enhancement adds a lot of work. Oh, that means I have to build the same code in like some server-side thing as I do in front-end code. But it doesn't have to be like that. For example, let's say you wanted to use the GitHub API and some JavaScript to show a list of your repositories on your site. Rather than using an empty div, you could add a link to your GitHub account. Once the required JavaScript is loaded, you use the JavaScript API, or the GitHub API rather, to get a list of repositories, replace that link with data from GitHub, and you're good to go. And if that file fails for some reason, people still have something usable, that link over to your GitHub account. People usually think of progressive enhancement as a JavaScript thing, but it applies to CSS too. CSS Grid makes it a lot easier to create really innovative layouts that were quite difficult in the past, but it only works in modern browsers. IE and older versions of Edge don't support it. But you can treat layout like a progressive enhancement. Browsers that support it will get the fancy layout, and browsers that don't will get a simpler single-column layout. It may not be as visually striking, but it's still functional. And at the end of the day, that's what users really care about. In many ways, the web is inclusive out of the box, and we ruin it with the choices that we make. Our designs and code break the way people who use keyboard, break the way that people who use a keyboard instead of a mouse navigate and move around the page. They break how screen readers consume the content. Our focus on only the latest browsers and fastest internet connections breaks large portions of the web for people in low bandwidth countries and lower income households. The web is for everyone, but too often we build sites and apps as if it's only for ourselves. This stuff can be hard, and I struggle with accessibility a lot too. One amazing resource is the A11Y project. It includes a ton of accessible design patterns and a checklist you can run through to make sure that your app or website meets all of the important criteria. I also love Dave Rupert's A11Y nutrition cards. They include quick overviews of keyboard behaviors, focus behaviors, and required HTML elements and attributes for a variety of JavaScript-driven components. It's just a really nice way to make sure that what you're building adheres to what someone who's using a keyboard or using a screen reader would expect to have happen. Building inclusive experiences often means saying no to people, even when it's uncomfortable to do so. It means saying no to other designers or developers on your team who want to do things in a way that breaks functionality for a segment of people. It means saying no to clients who want you to do something that's bad for the user. It means saying no to your boss when you're told to implement some executive's pet feature. It's hard to just say no, but you're a web developer, potentially some of you, and it's your professional obligation to speak up. Whenever I talk about building websites like this, I'm typically asked if any companies actually build websites and web apps like this. Yes, they do. I maintain a list of organizations that build sites and apps the lean web way at vanillajslist.com. It includes some pretty well-known companies. At the end of 2018, GitHub removed jQuery from their app, and instead of replacing it with a modern framework, they opted for native browser methods and custom web components. I had the opportunity to interview one of the developers from that team, Keith Serkel, about it. And he told me that one of their internal mottos is to build websites like it's 2005. Also in 2018, Netflix ripped React out of their default front-end page load. They still use React server-side for templating, but by using Vanilla.js for their client-side code, their load time and time to interactive decreased by 50%. And Meetspace is a video messaging app. They wrote their entire app entirely in Vanilla.js because they wanted the experience to be as fast as possible. Founder Nick Gauthier wrote, using this approach, we were able to create an incredibly fast and light web app that is also less work to maintain over time. So just to wrap things up quickly, some lean web principles. Embrace the platform, keep it small and modular, and remember that the web is for everyone. And if you remember nothing else from this talk, I want you to walk away remembering to think like a dev dinosaur and embrace old, stable, boring technologies and techniques. More bikes, fewer cars. And together, we can build a simpler, faster World Wide Web. Just a quick aside before we kind of wrap things up. I have put together a ton of resources for you guys over at gomakethings.com/JekyllConf. So if you found this interesting and you want to learn more, you can get the slides from this talk. If you prefer to read, there's a free ebook version that you can grab as well, and a ton of related articles, podcasts, and more. And with that, I will shut up.
Awesome. Thank you very much, Chris.
Yeah.
I haven't heard the term lean web before, but I 100% agree with the sentiment. I've seen React developers working on a static site, and they'll add React just so they can add, I don't know, like a slider or something. Mm-hmm. Yeah, and I believe just learning, at least even if you are going to use React, you should understand the basics of just native JavaScript and just HTML and CSS before you move to a framework like that. Yeah, what static site generator do you think best fits the lean web principles?
I think just static site generators as a whole 100% fit within this ethos. They keep such a narrow footprint. So I personally am a Hugo person because I find Ruby really confusing, and for some reason Go is easier to wrap my head around. Sure. If you're more of a JavaScript person, 11D is really awesome because the whole thing can be templated in just straight up like node style JavaScript if you want. If you're someone who's comfortable with React, but you want the benefits of static site generators, I hear good things about Gatsby. But I still know so many folks who love and use Jekyll. It's kind of like the OG in this game. They've been doing it forever, and they have a lot of really nice, helpful plugins and things which some of the others don't have yet.
For sure. Yeah, and I think it
But
fits into your lean web analogy really nice, because that's the thing I love about Jekyll is it just does one thing and does it really well. It's not trying to do anything fancy.
yeah, no, I'm a big fan of. I don't think you can go wrong with any of them. I want more people to use static site generators in general. So my thing is whichever one is easiest for you to get up and running with. I actually have ironically a student who I believe is on this conference who I tried to push him to go into Hugo for a really long time, and he just found Jekyll easier to grok, and
Sure.
that's what he ended up working with, and he never looked back. So yeah, whatever one is easiest for you, definitely go for. I think they're all great.
Nice. All right, I think we're out of time.
All right.
Thank you so much again, Chris.
No, thanks for having me. This was terrific. Thanks so much.